So a function is a specific type of relation. So relation is kind of the bigger umbrella, and then a function is the subcategory of a relation. So a relation just pairs inputs and outputs. So a relation is very general. Any set of inputs and outputs. Okay, ordered pairs, for example, show inputs and outputs, right? X and Y. Ordered pairs. So there really isn't anything other that defines a relation other than it has inputs and outputs. That's it. Any set of those is a relation. But a function will be a specific type where there are rules about what can be an input and what can be an output. Okay, so a function then, the definition of a function is it's a type of relation. So like I said, it's a subcategory. It's a type of relation, and this is the rule, where each input is only paired with one output. Each input is only paired with one output. So typically, they say input and output a lot. Inputs are X values, and outputs are Y values.
Wait 1 second. I have to write.
That's fine. I'm not moving on. Okay, so the key is, and this is what sort of helps me, at least when we're identifying functions when it's not a graph. You cannot have repeated inputs. So you can't have more than one X value in a set because it will be paired with two different Y's, and that's against our rule. We can only have one Y with one X. We'll look at a lot of examples of this. Okay? All right. And we'll determine whether or not it's a function by using this rule. Each input can have only one output. There's a couple different ways that they're going to show you relations, so sets of inputs and outputs, and we'll look at how you determine whether it's a function or not. So look at this one. The first way they're going to do this is with ordered pairs. Okay? The first way they're going to do this is with ordered pairs, and we need to determine whether those ordered pairs make a function or if they're just a relation. Yeah, these are coordinates. So remember, ordered pairs always go X, comma, Y. The first number in an ordered pair is always an X value. So we need to see, is every X with a different Y value? Or is any X value repeated with a different Y value? And if it is, it's not a function. So let's look at our X's.
Well, there's a repeating Y value. Twice.
Right. There's a repeating Y value, but what does our rule say? What does the rule say? Look back at the notes. It says no repeating inputs, which are X's. No repeating inputs, which are X's. Can we have repeating Y's? Yes. That is okay. So you're right. We do have repeated Y's. We have 2, 2, 2 with the first 3 ordered pairs, but those are Y's. Do we have any repeated X's? No. That means this is a function. This is a function because no X's are repeated.
And what exactly is the point of having a function?
Okay, let's do another one. So this one we would say yes. Is it a function? Yes. No repeated X values.
Wait, so if it wasn't a function, what would it look like?
Oh man, don't worry. We'll do one like that. Don't worry. Okay. All right, let's look at this set of ordered pairs.
It can't be.
So Malia, what do you notice here?
Is Matt gap?
There's no repeated Y. Oh wait. There's no. Oh wait.
A function can't have repeated
There's two
X
fours.
values. So we are always looking at the X values, which is always the first number in an ordered pair. Is there a repeated X value? Yes, the 4 comes up twice. If there's a repeated X value, then it is just a relation, not a function. So is this a function? No. 4 is repeated twice, like with 2 different y's.
For on big ideas,
Uh-huh.
like give us like yes or no.
Yeah. It'll give it you yes or no. Okay, let's do another one. Oh, did you finish that slide?